Here is the image. You see the direction of motion is roughly perpendicular to the direction of the sun. But when it came close to Mars, the HiRISE camera could look at it from the side.
On November 20th, 2025, a single scientific paper landed like a seismic charge, sending tremors through the foundations of astronomy. The author was Avi Loeb, a name now synonymous with challenging the comfortable consensus. His new analysis wasn't based on distant, fuzzy data, but on a crystal, clear image of the Object 3 Atlas, an interstellar visitor that has captivated and confounded scientists for months. The central claim was so direct, so profound, that it threatened to rewrite not just our understanding of this one object, but our entire place in the cosmos. The key piece of evidence came from an unlikely source, the Mars Reconnaissance orbiter. Its powerful HiRISE camera, designed to map the Martian surface in stunning detail, was turned outward, catching a glimpse of 3 Atlas as it journeyed through our solar system. What it captured was an anomaly of the highest order, a feature that simply should not exist according to the laws of physics as we apply them to comets. The image revealed a glowing, ethereal plume, a vast extension of material stretching an incredible 3,000 kilometers into the void. But this plume wasn't trailing behind the object, nor was it pointing toward or away from the sun. It was extending directly ahead of 3 Atlas, in its precise direction of motion. This single observation created an immediate and unavoidable conflict. Avi Loeb, looking at this impossible feature, posed a question that was both scientifically rigorous and deeply provocative. He asked, could this be a technological signature? Could we be witnessing a system designed to illuminate or clear the path of hazardous micrometeorites, a kind of protective shield for a craft on a long interstellar journey? It was a hypothesis born directly from the visual evidence, a logical if startling explanation for a phenomenon that otherwise defied explanation. Meanwhile, the official narrative from NASA felt strangely evasive. Just one day before Loeb's paper was published, on November 19th, the agency held a highly anticipated press briefing. The world expected to see the HiRISE images, the best data we had on 3 Atlas. Instead, they were met with a conspicuous absence. The images were withheld, and in their place were vague reassurances that all observations were consistent with natural cometary behavior. The timing was, to say the least, suspicious. The contrast between Loeb's direct analysis of the data and NASA's official silence was stark and unsettling. If you have been following the saga of 3 Atlas, and if something about the official story has felt incomplete, you are not alone. There is a reason the narrative feels hollow, a reason the reassurances ring false. It's because the evidence itself is telling a different story. In this analysis, we are going to break down the physics of the plume that shouldn't exist. We will examine the data that NASA seems unwilling to release. And we will look ahead to the critical observations in December that promise to provide a definitive, unavoidable answer. Hit subscribe now, drop a like, and let's break down the plume that shouldn't exist. Let's begin with the anomaly itself, the observation that breaks all the rules of cometary physics. The image in question was captured on October 2nd, 2025. The HiRISE camera on the Mars Reconnaissance orbiter performed a 3.2-second exposure, a brief moment in time that revealed something utterly unprecedented in the history of astronomy. There, in the cold, hard data, was a glowing extension of material pointing forward, leading the object through space. It was not a tail pushed by the solar wind, nor a jet activated by the sun's warmth. It was a spearhead, a luminous projection into the darkness the object had not yet entered. To understand just how bizarre this is, we need to quickly review how comets are supposed to behave. There are essentially 3 established models that explain the plumes and tails we see on these celestial travelers, and 3I Atlas violates every single one of them. The first model is based on solar heating and sublimation. As a comet approaches the Sun, its surface ice is warmed, turning directly from a solid into a gas. This outgassing creates a plume, but its direction is predictable. It should always extend primarily toward the Sun, where the solar illumination is strongest and the heating is most intense. The plume on 3I Atlas, however, is oriented perpendicular to the direction of the Sun, making this model an impossible fit. The second model involves radiation pressure and the solar wind. The Sun is constantly emitting not just light and heat, but a stream of charged particles. This solar wind acts like a constant, gentle breeze, pushing the gas and fine dust from the comet's coma directly away from the Sun. This is what creates the iconic, long tails that stretch for millions of kilometers across the sky. But again, the plume of 3I Atlas defies this. It points forward, against the relative direction of this solar pressure. A feat as impossible as a ship's sail pushing it directly into the wind. The third and final natural model is simple debris shedding. As a comet moves through space, it can leave a trail of dust and gas behind it, much like a truck kicking up dust on a dirt road. This material, slowed by solar wind drag, forms a trailing stream that marks the object's path. This is perhaps the most intuitive model, but it is also definitively contradicted by the HiRISE image. The plume is not behind 3I Atlas, it is in front. It is leading, not following. It is a projection, not a remnant. The physical impossibility of a naturally formed forward-facing plume cannot be overstated. You simply cannot have volatile materials, like water ice or frozen gases, sublimating in a region of space that the nucleus has not yet reached. The energy source for outgassing, the nucleus itself, is behind the plume. It's like seeing the exhaust of a car coming out of its front bumper, billowing into the road ahead. Likewise, the solar wind, a force that always pushes away from the Sun, cannot magically reverse direction and push material forward faster than the object from which it came. The physics simply does not work. Every natural mechanism we have ever observed or theorized would produce a plume pointing somewhere else, anywhere else, but directly forward. Adding to the mystery is the dynamic nature of this feature. Avi Loeb performed a crucial calculation based on the image. He determined that, at the typical thermal speeds of molecules sublimating from ice, it would take only a single day for that material to travel the entire 3,000-kilometer length of the observed plume. This is an incredibly important detail. It tells us that this is not some ancient, static cloud of dust that the object happens to be moving through. This is an active, ongoing, and rapid process. Material is being continuously and forcefully projected forward from 3I Atlas, replenishing this massive structure day after day. It is not a passive drift of particles. It is a sustained, energetic release. This observation transforms the plume from a strange curiosity into a profound physical puzzle that demands an answer. Faced with an observation that contradicts all known natural models, Avi Loeb did what good scientists are supposed to do. He proposed a new hypothesis that fits the evidence. He asked the question that has sent ripples of discomfort through the astronomical establishment. Could this be a technological signature of illuminating or clearing the path from any hazardous micrometeorites that may cause damage to a technological object? He isn't stating it as fact. He is presenting it as a possibility, a line of inquiry that is not just plausible, but is directly suggested by the strange physics on display. To appreciate the logic behind this, we have to consider the brutal realities of interstellar travel. 3 Atlas is moving at an immense velocity, screaming through our solar system at over 30 kilometers per second. At that speed, the space between the stars is not empty, it's a shooting gallery. Even a single, tiny grain of dust, no bigger than a speck of sand, becomes a lethal projectile. The kinetic energy of an impact is proportional to the square of the velocity, and at 30 kilometers per second, a minuscule particle strikes with the force of a high-caliber bullet. An object undertaking a journey of thousands or millions of years across the galaxy would face a constant barrage of these impacts, a celestial sandblasting that could erode and destroy any conventional spacecraft. Therefore, for any long-duration interstellar vessel, a forward-facing shield isn't a luxury, it's a physical necessity. You must have a way to protect yourself from this relentless micrometeorite bombardment. One of the most efficient theoretical solutions to this problem is not a solid physical shield, which would eventually be worn down, but an active defense system. You could project a field of energy or a cloud of particles ahead of your vessel. This system would be designed to vaporize, ionize, or otherwise neutralize incoming debris before it can make contact with the main body of the craft. It's a concept born from the fundamental principles of physics and engineering when applied to the extreme environment of interstellar space. Now, consider what such a system would look like to a distant observer. A mechanism that is actively vaporizing or ionizing dust and gas in its path would inevitably create a visible signature. It would generate a glowing cloud of plasma or excited particles, a luminous region of activity extending directly in front of the object it was protecting. This theoretical signature, derived from the logical requirements of interstellar travel, is a perfect and exact match for what the HiRISE camera captured. The forward-facing plume, an impossibility for a natural comet, is the expected appearance of a technological path-clearing system. This is what makes Loeb's hypothesis so compelling. It's not wild speculation, but an elegant solution that resolves a glaring physical contradiction. Loeb's analysis also opens up other technological possibilities that can be tested with further observation. He suggests, for instance, a dedicated search for mini-probes that may have separated from the main body of 3I Atlas. If this is an exploratory vessel, it might deploy smaller, secondary instruments to study its environment. These would be distinct from the fragments of a disintegrating comet. Natural fragments follow predictable gravitational trajectories, slowly drifting apart based on the forces of outgassing and rotation that broke them free. Technological objects, on the other hand, could exhibit behaviors that defy simple gravitational dynamics. They might show signs of coordinated motion, maintaining formation, or executing small course corrections for station keeping. The upcoming high-resolution observations could potentially reveal not just one object, but a small fleet, a possibility that would be nearly impossible to explain through natural fragmentation. The forward plume is the primary anomaly, but it may only be the most obvious sign of a far more complex reality. The response from the scientific establishment to these extraordinary observations has been, to many observers, as revealing as the data itself. The story of NASA's November 19th briefing is a case study in institutional defensiveness and suspicion. This event was scheduled just one day before Avi Loeb published his groundbreaking analysis of the HiRISE data. The timing itself feels significant, almost like a preemptive attempt to control the narrative before a more challenging one could emerge. The anticipation for this briefing was immense. The global community of scientists and enthusiasts expected it to be a landmark moment, the point at which NASA would finally reveal its highest resolution images of 3I Atlas and settle the fierce debate over its nature. The expectation was that the HiRISE images, with their unparalleled clarity, would be the centerpiece of the presentation. These images were supposed to provide the definitive proof, the ground truth, that would either confirm 3I Atlas as a strange but natural comet or validate the growing list of its anomalies. The stage was set for a major revelation. And then, the briefing happened, and the revelation was what wasn't there. The HiRISE images were completely and conspicuously absent from the entire presentation. No detailed photographs were shown, no analysis was offered, and most tellingly, no official explanation was provided for why this crucial data was being withheld from the public. Instead of data, the world was given a carefully worded official narrative. The NASA representatives spoke in vague terms about ongoing analysis, a common phrase used to delay the release of inconvenient findings. They offered broad reassurances, insisting that all observations to date were consistent with natural cometary behavior. This statement was made without presenting the very evidence that could prove it. It was an appeal to authority, asking the public to trust the conclusion without seeing the data that supposedly led to it. The entire event felt less like a scientific disclosure and more like a public relations exercise designed to calm nerves and dismiss controversy. The damning inference is impossible to ignore. If the HiRISE images had shown a perfectly normal-looking comet, they would have been the star of the show. NASA would have proudly displayed them on every screen, using the high-resolution data to decisively end the speculation and shut down the anomaly discussion once for all. The fact that they made the deliberate choice to withhold these images strongly suggests that the images do not support the simple, natural explanation. It implies that the photographs raise more questions than they answer, validating the very anomalies that researchers like Loeb have been pointing to. The absence of the images became, ironically, a powerful piece of evidence in itself, hinting that features like the forward-facing plume are not just real, but are so perplexing that the agency was not prepared to explain them in a public forum. This institutional reticence, this pattern of withholding data while issuing calming statements, did not go unnoticed. The public response has been a tidal wave of skepticism and a global crisis of trust in the official narrative. One of the most powerful indicators of this shift can be seen in the public letters that Avi Loeb has been receiving and sharing. These are not from fellow academics or scientists, but from thoughtful, engaged, and deeply concerned people from all corners of the globe. Their messages carry a unifying theme: thank you for pursuing the anomalies. Thank you for questioning the institutional story, and thank you for trusting the public to handle the truth. The voices are specific and powerful. A man named Giovanni Carbonella from Belgium wrote to Loeb expressing a deep sense of unease after watching the official briefing. He noted NASA's use of public relations language and the glaring absence of the promised HiRISE images, concluding that it highlighted the vital importance of independent scientific voices willing to ask difficult questions. He saw not a scientific presentation, but a corporate one, designed to manage perception rather than reveal truth. His sentiment was echoed by thousands who felt spoken down to, as if the truth was too complex or too dangerous for them to see for themselves. From the United Kingdom, a person named Kay sent a message of encouragement, praising Loeb for empowering ordinary people to stand by their own beliefs. This speaks to a deeper frustration: the feeling that scientific curiosity should not be the exclusive domain of a small, credentialed elite. Loeb's approach, which presents the evidence and invites open debate, is seen as a democratization of science, a stark contrast to the top-down pronouncements of official bodies. It gives people permission to trust their own eyes and their own reason when they see an anomaly that clearly defies the tidy explanations they are being given. A letter from Ruben Daniel in India placed the research into a grand historical context. He described Loeb's work as representing the transition from mythic intuition to scientific instrumentation, in the quest to answer humanity's oldest questions about our place in the universe. For him, Thei Atlas is not just an object, it is a catalyst, a moment where modern tools are finally being applied to ancient wonder, forcing a confrontation between our myths and our data. He sees the resistance from the establishment not as a scientific disagreement, but as a fear of crossing a profound philosophical threshold. Perhaps the most poignant and scathing critique came from Adam Gizik in Poland. His letter revealed the deep personal and generational impact of this scientific drama. He compared the institutional dismissal of Thei Atlas's anomalies to the plot of the movie Don't Look Up, a satire about a society in denial of an obvious and approaching danger. For Adam, the comparison wasn't just a clever analogy, it was a lived reality. He described sharing Loeb's work with his 9-year-old daughter every single day, watching her curiosity about the cosmos ignite and grow, even as he watched the scientific establishment try to extinguish that same spark of inquiry with reflexive denial. Adam's letter culminates in a devastatingly sharp observation. "Sometimes I feel," he wrote, "that even if Thei Atlas changed course and headed straight toward Earth, some of them would still insist that it was just a comet." This single sentence captures the core of the public's frustration. It articulates the fear that the scientific establishment has become so locked into its pre-existing beliefs, so defensive of its own authority, that it has lost the ability to recognize a paradigm, shifting discovery even when it is staring them in the face. These letters are a testament to a broader trend. The public is recognizing the defensive playbook. They see the pattern of dismissing anomalies, attacking the messenger, and circling the wagons around comfortable, familiar explanations, and they are refusing to accept it. As the debate rages and trust in the official narrative erodes, the entire world is now looking toward a single, critical window of time. The upcoming observations in December are poised to be the moment of truth, the point at which speculation must finally yield to definitive data. Avi Loeb himself has framed the stakes with unambiguous clarity. He states that the new data from large ground-based telescopes, as well as the unparalleled power of the Hubble and James Webb space telescopes, will inform us without a doubt whether the jets and plumes of Thei Atlas are natural or technological. This is not a hedge. It is a confident prediction that the evidence will be so clear it will force a conclusion. To settle this debate once and for all, these powerful observatories will focus on 3 key observational metrics. The first and most important is composition. Spectrometers will break down the light from the plume into its chemical fingerprints, revealing exactly what it's made of. A natural comet has a predictable chemical signature. We would expect to see specific ratios of common solar system volatiles water, carbon monoxide, carbon dioxide, methanol, and cyanogen. A technological signature, however, would look very different. We might find anomalous chemistry, such as a high abundance of noble gases like xenon or argon, which are ideal for ion propulsion. We could detect ionized metals or unusual molecular ratios that simply don't occur in natural cometary ice. The composition alone could be the smoking gun. The second key metric is speed. The velocity of the material being ejected from Thei Atlas will be measured with extreme precision. In a natural model, the gas molecules are driven off the surface by solar heating, and they move at predictable thermal velocities, determined by their temperature and molecular weight. There is a physical speed limit to this process. If the observations reveal that material in the plume is moving significantly faster than these thermal speeds would allow, it would be a direct contradiction of the natural outgassing model. Such high velocities would imply an engine, a propulsion system, or some other energetic mechanism, an internal power source actively accelerating the material into space. The third and final metric is the mass loading rate. This is a measure of how much material is being released from the object over time. For a natural comet, this outgassing rate should scale directly with solar heating. As the comet gets closer to the sun, it gets hotter, and the outgassing increases. As it moves away, the outgassing should decrease. It's a simple, predictable relationship. A technological signature could violate this in two ways. The mass flux might be far too high for the object's size and distance from the sun, or it could remain remarkably consistent, not changing even as the solar heating changes. A steady, powerful output of material would strongly suggest that the process is not being driven by the passive warmth of the sun, but by a controlled internal energy source. These three metrics, composition, speed, and mass loading rate, create a clear, falsifiable test. There is no middle ground here. The data that will arrive in December will either align perfectly with the known models of natural cometary behavior, or it will deviate in ways that are difficult, if not impossible, to explain without considering technology. If the data confirms natural processes, then 3I Atlas will go down in history as an extraordinarily weird and fascinating comet, a valuable outlier that expands our understanding of these objects. But if the data comes back anomalous, if the chemistry is wrong, the speeds are too high, or the mass flux is too steady, then the technological hypothesis will shift from being a fringe speculation to becoming the leading evidence-based explanation for what we are witnessing. This entire saga brings us to a deeper, more philosophical conflict that lies at the heart of modern science, the extraordinary evidence trap. For decades, the institutional shield against any serious investigation of anomalous phenomena has been the famous maxim: extraordinary claims require extraordinary evidence. On the surface, this sounds like a perfectly reasonable and rigorous standard. It is a safeguard against jumping to conclusions. But in practice, it is often used not as a tool for good science, but as a rhetorical weapon, a shield to protect the scientific establishment from uncomfortable conclusions. It becomes a way to create a goalpost that can be moved indefinitely, ensuring that the standard for extraordinary evidence can never truly be reached. When an anomaly is first detected, the establishment demands more data. When more data is provided that confirms and strengthens the anomaly, they demand even more data of higher quality from different instruments. At some point, this ceases to be a genuine quest for truth and becomes a tactic of perpetual deferral. The standard is set so impossibly high, not because the existing evidence is weak, but because the conclusion it points to is profoundly disruptive to the existing paradigm. 3 Atlas is a perfect case study of this trap in action. Because it isn't just one anomaly we're talking about, it's an entire collection of them. A persistent pattern of strangeness that defies easy dismissal. Let's list them, one by one, to appreciate the cumulative weight of the evidence. There is the persistent sunward anti-tail, a feature that should not exist. There are the methanol to hydrogen cyanide ratios, measured to be 10 times higher than in any comet ever recorded in our solar system. There are the powerful X-ray emissions detected when the object was far from the sun. A phenomenon that has never been seen before and which occurred without the presence of the cometary gases thought to be necessary for it. There are the unexplained, dramatic color shifts from red to green and then from green to blue, all while the object was moving miles away from the sun, contradicting all known models of cometary fluorescence. On top of that, there is the nucleus itself, which has remained a single, non-fragmenting body despite experiencing extreme thermal stress that should have caused it to break apart. We have observed highly organized, stable jet structures that hold their shape and orientation despite the object's rotation, suggesting they are not random outgassing events. And finally, we have the crowning anomaly, the forward-facing plume, a feature that, as we've discussed, directly defies the fundamental physics of natural comets. The great failure of institutional science in this case is its insistence on treating each of these anomalies in isolation. Each one is dismissed as a curiosity, a puzzle to be solved later, while completely ignoring the undeniable and powerful pattern they form when viewed together. This isn't just one strange thing. This is a cascade of strangeness, all pointing in the same direction. We are now standing at a fork in the road of scientific history. The climax of this extraordinary story is imminent. On December 19, 2025, 3I Atlas will make its closest approach to Earth, providing an unparalleled opportunity for observation. At that moment, every major telescope on and off this planet will be pointed at it, collecting the data that will finally force an answer. Two possible futures await us on the other side of that encounter, and they could not be more different. In the first future, outcome A, the new data confirms natural processes. The spectrometers find familiar chemistry, the velocities are within thermal limits, and the mass loading rate perfectly matches the models of solar heating. In this scenario, the mystery is solved. 3I Atlas is declared a natural object, albeit one of the most bizarre and unique comets ever discovered. It becomes a new and fascinating textbook case, a celestial oddity that pushes the boundaries of our knowledge but does not break them. Science celebrates a puzzle solved, and humanity moves on. But there is another possible future, outcome B. In this future, the data confirms the anomalies. The spectra reveal chemical compositions never before seen in a comet. The velocities are measured to be far in excess of what natural processes can produce. The mass flux is shown to be steady and powerful, independent of the sun's influence. In this scenario, the technological hypothesis ceases to be speculation. It becomes the most logical, most parsimonious explanation for the cumulative evidence. This outcome would force a paradigm shift of historic proportions, a moment that would change our understanding of the universe and our place within it forever. What makes this moment different is the intense public scrutiny. The letters sent to Avi Loeb from around the world are more than just fan mail. They are a signal. They show that the world is watching, that people were engaged, and that they are capable of distinguishing between genuine scientific inquiry and defensive public relations. The institutional playbook of dismiss and delay will no longer work when millions of informed citizens are paying attention to the data. So, as we await the flood of data in December, the question is now yours to consider. What do you think that forward-facing plume is? Is it some unknown form of natural outgassing that just happens to defy all known physics? Or is it something clearing its path through the cosmos? Drop your theory in the comments below. Be sure to subscribe, because you will not want to miss our breakdown of the December data as soon as it is released. This is the moment when speculation finally ends and the hard evidence forces an answer that no one can ignore. And please, share this analysis. Counter the simplistic, dismissive, it's just a comet, narrative with the undeniable evidence of the plume that shouldn't exist. The truth is coming,